see Kate Johnson.
Hello
so
and
shout
welcome
out
everyone. Yeah.
Oh, go ahead.
Yeah. Hello everyone. I'm Peter, and this is the Ethereum Engineering Group meetup. And today we've got Oren from Gnosis to give a talk. So Oren, please introduce yourself.
At Gnosis on a team called Gnosis Guild. We build a whole bunch of, I guess Gnosis kind of more generally just builds all kinds of infrastructure for the Ethereum ecosystem. And then my team, Gnosis Guild, we work on kind of DAO specific infrastructure. So mostly kind of needs driven development for the Gnosis DAO. But we tend to build in such a way that kind of everything we build is kind of generalizable and should be usable by other projects. And Gnosis Guild is very much in the habit of and kind of advocating for a kind of modular way of building all kinds of DAO tools, which is what we'll talk about today.
Sounds awesome. So please go ahead and share your slides. And so just so everyone knows, Oren said before that he's happy for us to hammer home questions at any and every moment.
Yeah. Feel free to interrupt me anytime. I'm reasonably good at task switching, so we can dive into answering questions. And I can jump back into the presentation. The talk will probably go for 15 or so minutes, and then after that we can go into kind of heavier Q&A if folks have questions, and if not, then I'll probably just jump in and do a bit of an ad hoc demo of actually using some of the principles that we talk about and using kind of the Zodiac standard to build a module to control a DAO with some very trivial functionality, since it's we'd be building it live as we go. But yeah, we'll go ahead and jump in and get to it. All right, so today I want to talk about this funny little concept called pipes. Pipeline programming is an approach where one breaks a problem into a number of small steps, each of which can then be performed by a simple program. This type of componentization is sometimes called pipethink, in which, wherever possible, a programmer relies on a pre-existing collection of useful stages. So this methodology relies heavily on the reuse of a set of components rather than building monolithic applications. So in Unix-like environments, pipes are represented by a vertical bar, which lets you pipe the output of one command into the input of another. And because each process takes text as input and provides text as output, they can be chained together in arbitrarily complex combinations to create useful or fun, in this example, systems. So this is just a silly kind of trivial example here where I'm kind of piping echo into another command to make a little cow say moo, and then to make my cow colorful. So fun systems here, but in practice, it's much more useful. So similarly, modern programming makes use of a ton of standardized protocols and interfaces to allow programmers to feed one another's inputs and consume one another's outputs. However, these interfaces often become centralizing forces. Someone ultimately owns and controls the underlying data, along with access to it and the bill for maintaining those resources. And anything built on top of that access or data takes on some existential risk, creating strong incentives for large monolithic ecosystems to be built around the choke points for control and access to that data. So social networks like Twitter, Instagram, Facebook, etc., are kind of canonical examples of this. Gargantuan walled gardens with incredible inflows of data ready to be consumed by humans and machines, but ultimately controlled by one entity. These kind of represent an existential risk for anything built on top of them. So for example, if at any point Twitter decides to change or restrict its API, then the lovely command line interface for Twitter that I have on screen here could immediately break. And so unlike the pipes you might use on your local machine to make colorful ASCII mooing cows and other more useful things. The pipes to Twitter are permissioned. The justification for this essentially boils down to the fact that someone has to own, operate, and pay for the infrastructure that it runs on. And of course, because controlling access to this data can be wildly profitable. But for a growing number of use cases, the relatively recent innovation of permissionless shared execution environments, like the Ethereum virtual machine, provides an avenue to eliminating much of that existential risk. That avenue is open access to data and communication, data and computation. So because of the relatively strong guarantees around access and control, the EVM allows for permissionless pipethink. And as a result, there's this emerging ecosystem of reusable components, allowing for ever more complex and novel combinatorial systems rather than monolithic applications. One of the best examples of this is the proliferation of the ERC20 standard. It's a standard interface for tokens in the Ethereum virtual machine. So by writing contracts that conform to the ERC20 standard, that take ERC20 tokens as inputs, that expose ERC20 token interface, so as their kind of output, or that do both, users are able to string together arbitrarily complex combinations of systems to create useful or fun token derivatives. A common and relatively simple example would be depositing ETH into a maker vault, which returns DAI, an ERC20 token, or depositing ETH into a maker vault, which returns DAI, depositing that DAI into a 3-curve pool, returning that 3-curve token, depositing that 3-curve token into a Yearn vault, which gives you this Y 3-curve token. And so the deeper into the kind of DeFi ecosystem you go, the more complex and convoluted these paths of chain systems become. Each system taking an ERC20 token as an input and returning its own ERC20 token, representing the position in that system as its output. But breaking away from monothink, the inverse of pipethink, or the tendency towards monolithic systems, is really hard. It means thinking smaller and accepting that what you're building will likely be used as just one part of a much larger whole. It often means relinquishing some measure of control over the user experience. It means embracing composability, and it requires leaning into the fact that your things will be used in weird, wonderful, and entirely unexpected ways. So in 2013, the thing that got me really excited about cryptocurrencies and about the idea of Ethereum in particular, the thing that turned it from kind of an idle curiosity into an infatuation, to something that I wanted to invest my money, my time, my effort into, and the thing that has most radically kind of shaped the last decade of my life was the idea of DAOs, decentralized autonomous organizations. So to me, DAOs have been this kind of beacon of hope, illuminating a path toward a future where humans from any corner of the globe could freely choose to come together to collectively build the change they want to see in the world, or like collect JPEGs and all that kind of stuff. So without the need for anyone else's blessing or approval, they can essentially rally around an idea and execute on it. So to me, DAOs are a foundational infrastructure for Web3, for a web without walls. But due in large part to how early they all were in Ethereum's life cycle, the lack of mature tooling and the lack of mature use cases when they started design and implementation, all of the well-established EVM-based DAO frameworks, to some extent, fall victim to this monothink idea. These frameworks, from the DAO to Aragon, Colony, DAOstack, Governor, Moloch, are all designed as monolithic systems built around their own core contracts. To be fair, they each implement their own version of modularity within their own walled gardens. They have apps or extensions or modules or plugins, which is still a vast improvement over the kind of permissioned access that's typical for more traditional web applications and APIs. But there's a little to no concept of composability between these various systems, aside from what's baked into Ethereum by default. So each one of these systems was built as the center of its own universe, with each app, extension, module, or plugin being built kind of bespoke for that ecosystem, which essentially further raises the walls around its garden. In Web 2, some people might celebrate this and call it a moat. In Web 3, this is kind of an anti-pattern. We can and we should do better. So what does better look like? We should be building our DAO tooling with standard inputs and outputs so that users can compose them in whatever weird and wonderful combinations they like. This doesn't mean tearing everything down and starting again from scratch, but it does require a bit of a reorientation of what we consider the center of a DAO. So the key insight here is decoupling account from control mechanism. Decoupling the thing that represents your DAO on chain, its avatar, if you will, and the thing that's the thing that kind of holds tokens, controls systems, and is referenced by other systems. Decoupling that from the logic that makes it do things, the logic that controls it. So with this simple reorientation, treating new and existing tools as pieces to be plugged into a much grander design, we open up the possibility for permissionless pipethink in the context of DAOs. And in doing so, we open up the possibility for more flexible and resilient organizations that are much more capable of adapting to changing environments. So to this end, we, Gnosis Guild, created Zodiac, an open standard for composable DAO tooling, along with a collection of tools that we've built to that standard. Zodiac enables DAOs to take full control of their composition, to mix, match, stack new and existing tools and frameworks to find the combination that best suits their needs, and to do so in a way that doesn't inhibit their future growth and evolution. Zodiac treats a programmable account like the Gnosis Safe as an avatar for the DAO. And then anything that can make calls to the exec transaction from module function on that avatar can be enabled as a module. Modules would typically be contracts that implement some logic to extend the functionality of the DAO's avatar, adding voting mechanisms, giving specific permissions to some users, allowing members to exit or rage quit with their share of the DAO's assets, and much, much more. And then modifiers, contracts that would sit between an avatar and its modules to, well, modify their behavior. This could be things like enforcing a time lock on proposals, enforcing access control for specific addresses to be allowed to call specific functions. And so with these three primitives, avatars, modules, and modifiers, we're now able to use this concept of permissionless pipethink to build composable DAO tooling and much more flexible and robust DAOs. So I've used a bunch of my time here today to talk about how composability is valuable in the context of DeFi and DAOs. But this extends well beyond just DeFi and DAOs. I think for Web3 to truly express itself, pipes must be pervasive throughout the ecosystem. With everything we build in Web3, we should be conscious of the design decisions we make that might enable pipethink, or conversely, encourage walled gardens. Individually, we might need to think a little bit smaller so that we can collectively think bigger, allowing more complex systems to emerge organically. But this is not prescriptions so much as it is a warning to all of those who would seek to build and defend a moat on our shared virtual machine, to build systems incapable of composition. To those people, I would say this is a pattern of the past. It's an anti-pattern in Web3, and it's a pattern enabled by permissioned access to and control of data. It's a pattern which has been made redundant to a certain extent in our version of the internet, made redundant by our shared virtual machine. And I think the future will be dominated by much more emergent systems, organic compositions of many discrete and disparate components in combinations never dreamt of by their creators. So rather than seeking to build walled gardens, I'd say join us by adding to and building on this infinite garden. Join us by building and more importantly, by using the pipes in this web without walls. Thanks. That's the I guess end of the talk. Happy to jump into Q&A now if anyone has any questions. And I guess just chill if you do want to connect after the talk, then you can find me on Twitter at Oren Macmillan, or you can find Gnosis Guild at Gnosis Guild. But yeah, I'm here now. We can chat away, and if once we're done with questions, or if no one has any questions, then we can dive into a quick tutorial on actually building a module for a Gnosis safe that does something silly. So yeah, I'll pause there for a second and just open it up to questions.
Yeah, and so thank you as a starting point. And are there questions? Okay, I've got one. So is this, so I assume it's, I mean, it feels like we're talking about interfaces, but probably something more than just defining some interfaces. That's correct, isn't it?
Yeah, I mean, so interfaces are one part of this. I think having standard interfaces that you can use as a shelling point is pretty integral to composability actually working. But I think more than, or kind of in addition to that, there's the mindset of the people that are actually building tools. So like it's defining interfaces is only the kind of first step towards it. The other kind of really critical component is getting momentum behind, getting kind of people who are building and using tools to actually understand the benefit of this type of composability, both for their own systems, but then also for the ecosystem as a whole. I think that's probably the more critical phase of this getting this kind of philosophy to be kind of pervasive throughout the ecosystem, making it be the standard that people kind of expect when they are interacting with a tool or kind of building a new tool.
Okay. I know I'm thinking having any, as you said right at the start, having an example will make this so much crystal clear. Does anyone have any questions before Oren dives into doing an example that helps crystallize it for us? No? Okay, over to you then. Let's see this example, and then we're going to walk away knowing. I mean, I sort of think I understand, but I'm not quite there, I think. But I think having a worked example is going to help a lot.
Yeah, no worries. So this is a tutorial that's up on our wiki, which is yet to be published. I think it's actually posted on our old. Let's see. I'll track that down later, but it's on our old docs as well. But we are about to launch this Zodiac.wiki. This is just a staging server for it right now. And here's a kind of tutorial. We'll go through this live, and hopefully it all works as intended. It should. But the idea here is basically to build a module and kind of control a Gnosis safe via some additional logic that we implement as a module. Hopefully this helps to kind of crystallize some of the context, some of the kind of concepts here in terms of permissionless kind of modularity, this permissionless pipe thing. So in this case, we're just going to use Remix. This is a web-based Ethereum IDE, really useful tool. And what we're essentially going to do is just build a contract that has a, we're going to build our own custom module that just pushes a button, essentially. So we have this gist here, button.sol, and literally defines one function where where you can call it push button, and it's just going to increment this button pushes variable and emit this little button was pushed event. So trivial, super silly little contract, but the kind of catch here is that it can only be pushed by whoever the owner is. So when we deploy it, it'll be, the owner will be set to whoever deployed the contract, and then we're going to transfer it over to our mock safe. In this example, this is just a contract that exposes some modified versions of some of the core functions for the Gnosis safe, and kind of demonstrate how we can then extend the safe's logic with our own custom module, so that we can change the ways in which we can trigger the safe to actually execute things. And so in the context of a DAO, we're essentially building this module to extend the functionality of our core DAO, the avatar to our DAO. So I'm going to grab this gist. I'm going to open it up in Remix. And you see that it gives us our 3 contracts. It's going to compile them automatically as we go through. And so what I'm going to do is we'll start off just working in the local virtual machine here in Remix. It's taking a little longer to compile than it normally would, which is surprising. Let's try again. This might be the live demo gods frowning on this presentation. I'm going to hit refresh and see if I can get it to work as intended. It might be because I had turned off my VPN earlier. It might have broken something with my connection to Remix, or it might be the other way. It just doesn't like my Australian IP address. No, okay, cool. So it's compiled now. Great. So we're going to deploy our button to our local EVM environment. Hit the deploy button. We see down the bottom here that our deploy transaction went through, and we can see here we now have a button deployed. If I hit owner, it's going to query the owner variable and return my address in this local virtual machine. If I hit pushes, we'll see that it's currently set to 0. So this is our pushes variable here. And then if I push the button, because I'm currently the owner, our transaction will confirm. And now if I hit pushes again, we'll see that it's incremented to 1. So we have this very simple contract here, which is essentially just a button that the owner can push whenever they like to increment it to 1. Push it again, increment it to 2. So the next thing that we're going to do is we'll open our mock safe, and we will go ahead and deploy this mock safe over here in our virtual machine. And if I wanted to try to trigger the mock safe to push the button, I'm going to jump back over to the tutorial here and scroll down a little bit and grab the function selector for the push button function. So I could attempt to make my safe push the button. And what we'll see is when I do this, the transaction is going to fail. And it's basically just going to fail because my mock safe here is not the owner of the button, so it cannot push it. So we're going to transfer ownership of the button over to our mock safe. Let's just make sure I got the address right there. Looks good. So we'll transfer ownership. And now if I try to push the button, we'll see that the transaction fails because I'm not the owner. But I'm just going to query pushes again just to validate. Has not incremented beyond 2. So now if I hit transact down here, this transaction should succeed, and I should be able to see up here that pushes has incremented to 3. So now our safe is our mock safe is the owner of our button contract, and it can push the button. This exec function here I've modified significantly from the normal Gnosis safe. This is normally the entry point that we would use to do the multi-sig. So it has a whole bunch of additional fields, one of which is a field that includes all of the signatures from the signers. So you obviously need to have a threshold of signers in order to execute something. In this case, literally anyone can come along and hit this exec function to make this mock safe do whatever you want. So don't ever try to use this mock safe in anything valuable at all. It's totally unsuitable for anything in production, but great for demos like this. What we're going to do now, though, is build a module that's going to interact with its exec transaction from module function. And so this one does actually have some protections on it. So if I wanted to, or some validation on it. So if I wanted to try to call the same function on using the exec transaction from module endpoint here, or entry point, then when I hit transact, this one should fail. And it's going to say unacceptable address or unaccepted address because my address here is not enabled as a module on this mock safe. So what we're going to do here is build, well, one thing we could do is just enable my address as a module on the mock safe, and then I'd be able to use this entry point. But in production, kind of enabling an EOA as a module on a safe would just give the safe, give that EOA unilateral control over the safe. It means that basically that EOA now controls the safe. It doesn't need permission from other signers or anything. It can make the safe do anything it wants. So it's pretty dangerous to enable an EOA as a module. What you want to do is create a contract that implements some specific logic around when, why, and kind of how the module is able to trigger the safe to do things. So in our case, it's going to be really simple, and it's not going to, it's basically just going to allow anyone to come along and trigger the safe to press the button. So remember, our button originally, only the owner can press it. And this will still be the case, only the owner will actually be able to press the button. But the module that we're going to build will allow anyone to trigger the safe to press the button. So the safe is still the thing pressing the button, but anyone can tell the safe to press the button, essentially. So we're implementing some additional control logic that basically opens access to this push button function. So I'm going to go over to our tutorial here, and actually, yeah, before we go any further, what you'll see here about this contract, kind of where it starts, is that we are importing module.sol. If I open up the Zodiac repo here, you'll see that module.sol basically implements a whole bunch of functions and variables that are essentially the standard that we are trying to kind of coalesce around for how composability can work in the context of DAOs. It is actually also implemented as an EIP. That's EIP 5005. So Zodiac avatar accounts, if anyone wants to go and check this out, this is the kind of more formal definition of the standard. So we have the iAvatar interface, which basically exposes enable module, disable module, exec transaction from module, the endpoint that we're using today. And then let's see. And then from our implementation here, we have our implementation of the standard is kind of opinionated about some of the variables and things that should be included with a module. And essentially what our module.sol does is expose this internal function here that your module can use to trigger the safe or the avatar to do things. So you create some logic around when, why, and how your module calls exec to trigger the safe to do things. In our case, we are going to grab some code here from the tutorial. I'll just copy and paste it so that I don't fumble around with it live on the call here, but we can walk through kind of what this is. So we have one variable button, which is the address of our button contract. We'll set that when we deploy the button. Let's close out some of these folders. There we go. So we'll set that when we deploy our button contract, and then we have this push button function. And what this is going to do is just call the exec function, the internal exec function that we've imported from module.sol. It's going to set the to address, as in the address that the safe will call, to button, the value, as in the amount of ether to send with it, to 0. It's going to encode the push button function as the push button function selector as the data, and then it's going to select call, as in the type of call that it's going to make. Your options here are call or delegate call, but in our case, call is what we want, because we want the safe to be message.sender when it calls to the outside function on the button contract, when it calls the push button function on the button contract, as opposed to it essentially doing a delegate call, which means kind of treating it, using the logic from the button contract, but treating it as if it's an internal function to the contract, to the safe. So yeah, really simple module here, but hopefully illustrates the kind of concept here where we can very easily kind of implement additional logic to change how our avatar, our mock safe in this example, is controlled. So now what we're going to do is jump over to our local virtual machine again. We'll deploy and no, we won't. Oh, right. I almost forgot. Well, I did forget. So our compiler is complaining at us right now because it's saying that this should be marked as abstract because there's a handful of functions that are required that have not been implemented yet. So I'm going to scroll down a little bit here and grab some more code. We have a constructor and a setup function. And these are, again, kind of opinionated parts about this that we add to our implementation. This is not something that's required by the standard, but it is something that makes it easier for other users to go and deploy. And it's essentially the pieces of this that make your contract factory friendly. So if we go back to contracts here and jump into the factory folder, we have this factory friendly.sol, which is imported by our module.sol. And basically it just has this requirement to implement the setup function, which initializes your contract. So you see here that the way that we implemented it, we've got a constructor, which is the function that's called when you first deploy a contract. And all it's going to do is take the parameters, ABI encode them, and then pass them to a setup function. And then the setup function is going to decode those parameters and then use them to set a handful of variables. We've been really lazy here and just set the avatar, the target, all to owner, and then transferred ownership to our owner variable as well. in production, you want to be able to define those things separately because there are a handful of cases where they are not the same thing. And just to kind of disambiguate them, avatar is the address that will ultimately execute the transaction. So this is the mock safe in our example. Target is the next address in a chain of modules and modifiers that should ultimately lead to your avatar. So if you have, so an example of this would be if you have a delay modifier, which is a modifier that essentially enforces a time delay between when a module passes in a transaction to be executed and when it can actually be sent to the avatar to be executed. Then from the point of view of the module that has this time delay being enforced, the target is the delay modifier, and then the avatar is the safe. So it's important that those two things be able to be disambiguated or can be set to separate variables. And then owner is the address that can control kind of permission functions, usually to set different variables. And so it's again kind of important that this be able to be disambiguated from the avatar and the target, because there's scenarios where you might want to have the owner be different from those things. You might want to set the owner to the address 0 so that you lock the state of the module, or you might want to have some checks and balances between different components of your DAO. And so having the owner be something different from the avatar means that some other mechanism may be able to kind of be a kind of check on the power of the avatar. So again, disambiguating those things in production is really important. In the context of this, it's not. So we just are lazy and set them all to the same thing. Now that we've put in our setup function and our constructor, the compiler stopped complaining at us. I guess the last thing here to quickly go through the kind of why of the setup function is it's implemented as part of this factory-friendly contract. And basically what this does is make it friendly for this module proxy factory. And this module proxy factory essentially allows us to deploy a very, very minimal proxy that is not upgradable, that you can use as an alternate to deploying the entire contract. So someone can deploy a master copy, and then any number of people can deploy proxies that use the code from that master copy. So it basically just radically reduces the deploy cost with the trade-off of a slightly higher cost each time you call the contract. In this case, the contract that actually gets deployed, the proxy contract, is tiny. I believe that this is the smallest and most efficient proxy contract available. It's based on another EIP that I can't remember the number of off the top of my head, but this minimal proxy contract, let's see, Google might save me here, 1167. So it's based off of this 1167 minimal proxy contract, although I believe ours is slightly more efficient because we changed one opcode. I can't remember exactly what it was now, but yeah, ever so slightly more efficient than the minimal proxy contract, just as a small brag. Anyway, we'll get off of the factory-friendly stuff for now and back into our module and using it to control our safe. So now that we've got our module compiling, we'll jump in here, go to the bottom, select my module, and we're going to deploy it. And we're going to set our mock safe as the owner, and we're going to set our button as the address. We'll hit transact, and see that one has succeeded, and so now we have our module deployed. Go back up here, requery owner, so we can see owner is the safe's address, pushes is still 3, but now I have this additional module with a whole bunch of extra functions that were imported by module.sol. The important one for us, I guess we can query avatar just to confirm that the avatar is pointing to our mock safe. The important one here is that I now have a push button function on my module that should be able to trigger the safe, our avatar, to push the button over here. So I'm going to hit push button, and oh, it's failed. The reason that it's failed is that our mock safe needs to enable this module as a module before it gives it permission to actually call this exec transaction from module function. So I'm going to go ahead and drop in the address of our module into this enable module function. We'll enable it as a module. And now when we hit push button, we should be able to see that our push counter has incremented to 4. I'll just push it again just for the fun of it, incremented to 5. So yeah, using this relatively simple kind of abstraction, or this relatively simple kind of standard in terms of the entry point that we use to control an avatar, we are able to arbitrarily extend its logic and whatever way we like. The really nice thing with this standard is that it doesn't invalidate any of the existing DAO tools. Literally every DAO framework has the ability, or I should say the vast majority of DAO frameworks have the ability to make arbitrary function calls. And so they can call this exec transaction from module function on a safe. So essentially, for existing DAO frameworks, if you're wanting to kind of adopt this as your kind of default way of operating, essentially what you do is say, rather than the kind of core contract in our DAO framework being the avatar, we're going to defer to a Gnosis safe or something else that kind of implements this same interface, and have that be the avatar for the organization, have that be the thing that holds tokens, controls systems, all that kind of stuff, and then enable the kind of core contract in our DAO framework as a module on that safe. So kind of one step removed enables this huge amount of flexibility in terms of how the organization is able to grow and adapt over time, add and remove different control mechanisms to make kind of more complex and interesting systems. So yeah, I guess that's the whole tutorial. We've deployed a module that now can control our safe with admittedly very simple instructions, but should kind of illustrate the concept. We can go and do the same thing on Rinkeby if we want to show it on a kind of public test net, if other people want to be able to push the button, or otherwise, if we just want to open it up as another opportunity for questions, then we can go ahead and do that.
Yeah. Yeah, so if you can hear the dogs in the background, please ignore them.
No worries.
So I'm just thinking through. So the Gnosis safe is a multi-sig wallet sort of thing, where you get people to vote, and then you execute a function call on some other contract. So, and then but then this pre-module, so that you were working on, would be, say, used for working out kind of like voting rules, I think.
So I think, so the Gnosis safe at its core is essentially a programmable account, right? The default way of operating a Gnosis safe is as a multi-sig, and kind of multi-sig has this privilege in the current implementation of the Gnosis safe because it uses its own entry point. It has this exec transaction function that you would use to trigger things with the multi-sig, and it has a whole bunch of additional parameters again, one of which is the signatures that the exec function has to validate in order to actually trigger the safe to do things. But again, under the hood, it's really just a programmable account. And with this additional entry point, exec transaction from module, you can change it arbitrarily. And so like, if you want to have a good kind of illustration of a kind of progressive decentralization pathway here might be that you originally spin up a safe as a multi-sig. Then maybe you think, okay, now we'd like to get community input on it, but not kind of formal control. So we'll go and spin up a snapshot instance where the community can kind of vote on what we, the multi-sig signers, do, but they don't have any kind of formal control. A next step might be to add some measure of formal control in parallel with the multi-sig. So you might deploy, we have this reality module and safe snap plugin to Snapshot that allows, via the Oracle reality.eth, allows you to kind of bring the off-chain voting from Snapshot on-chain and then autonomously trigger execution from the safe. So you plug this reality module into the safe, and this now becomes an additional control mechanism to the safe that can basically bypass the multi-sig signers. So any module enabled on the safe does not have to get permission from the multi-sig signers to trigger the safe to do things. It has unilateral control over the safe. You can have as many modules enabled as you want, and then you can have as many modules enabled in parallel with also having the multi-sig signers enabled. And they all have independent control over the same safe. And so in this kind of third step there, where you've got safe snap and this reality module enabled in parallel with the multi-sig signers, either or both can control the safe at the same time. And so I'd argue that the kind of mechanism that ultimately controls it is the one that can act fastest, which is probably the multi-sig signers. So what you may want to do then later is restrict, say, what the multi-sig signers can do. You know, the next step in this progressive decentralization journey might be to say, okay, we trust these multi-sig signers, but we don't want them to have unilateral control over the safe anymore. We only want them to have access to specific functions. Like maybe we want them to have veto rights over the things that come through the DAO, just in case there's a malicious proposal that makes its way through. So we're going to put this scope guard on, limit the scope of what they can do, so they can only call this this veto function. And then maybe at some point in future, the DAO is comfortable and says, okay, we're ready to go, kind of no hands, and we're just going to remove all the multi-sig signers altogether. So now the only way to control it is via this this module that you've enabled, or via the kind of combination of modules that you've enabled.
Yeah, okay, that makes sense. So you could have it as a gradual progression. Yeah.
Yeah.
Sandra, what are your questions? I can see you're thinking things through there, but what are your thoughts?
Not specific questions. I just found the demo really helpful, Oren. That was very enlightening. But I also noted, I mean, you mentioned early on about being involved in DAOs very early on. And I was just interested to get your perspective on how things have changed, where you think there's still room for improvement, what the main challenges are and the main benefits for people who are not that familiar with DAOs.
Yeah, I'll start with room for improvement, because that's something that I'm really opinionated about. So obviously one place where I think there's a ton of room for improvement is in this kind of modularity and composability piece, which is obviously what we've been talking about today. That aside, I think one of the other kind of big limitations to how most DAOs operate right now is that they essentially expect everyone to vote on everything. You know, you have some voting mechanism, you know, all the token holders get one vote per token or something like that. And every decision the DAO makes is basically a referenda on those token holders, which is insanely inefficient. So like traditional firms kind of scale by delegating decision-making authority to people at kind of different levels in the organization, giving people or kind of groups of people autonomy over some decisions within some limited scope. I think probably adopting similar patterns in a lot of contexts is going to be really critical for DAOs being able to scale beyond kind of their current scale. But then also finding other mechanisms to allow things to allow for the DAO to execute on things without having to go through this kind of referenda process. So really kind of great examples of this are things like distributed consensus in terms of like the Ethereum network or the Bitcoin blockchain, where you could essentially see these as large DAOs who have a very kind of tightly scoped role in terms of what the DAO actually does. The DAO for the Ethereum network is essentially the combination of miners, or soon to be kind of validators, that monitor the kind of mempool and validate blocks and try to add new blocks to the chain of blocks that make up the kind of history and the kind of upcoming state transitions for the chain. So the DAO is kind of really tightly scoped there, but because of its kind of tight scope, it's able to be totally permissionless. Like anyone can self-select as a miner or a validator and start participating in that kind of game of consensus. Another really great example of this is mechanisms like quadratic funding, where the allocation of budget comes from the kind of independent inputs from a whole bunch of different folks, essentially acting in their own mutual self-interest. And I think that's the really kind of key piece to this, is like enabling mechanisms where you get the desired result. In the case of the Ethereum network or the Bitcoin network, the desired result is this kind of secure, highly available chain. In the case of something like quadratic funding, the desired result is a well-allocated budget towards kind of public goods. But engineering mechanisms where you get a desired outcome from the uncoordinated inputs of a kind of diverse and ideally permissionless set of inputs from people essentially acting in their own mutual self-interest. So as a miner or a validator, I'm acting in my kind of self-interest in that it's profitable for me to take on this activity, but it's this kind of mutual self-interest because everyone who is doing it is doing so for a profit, but then also to kind of propagate this network. And then similarly for kind of quadratic funding, you're contributing to the projects that you value, and kind of if you're doing it according to the kind of how the QF algorithm or how kind of rational behavior predicts, then you're kind of contributing to the projects in the amount of kind of utility that it provides to you, or the utility that you get out of it, and then it's allocating the budget according to the kind of aggregate utility for everyone who is contributing. And yeah, so I think like though, stepping back to the original question, there is like I think finding ways to kind of create delegation of responsibilities, and or finding ways to have kind of desired results be emergent behaviors from people acting in their own kind of mutual self-interest. I think two ways which DAOs, two kind of paths that DAOs need to start exploring in terms of how they might scale their operations so that they can move beyond a point where essentially everyone votes on everything.
Oh, thank you for your insight. It's really interesting, especially someone who's had your experiences, like we wouldn't have that context and understanding of what some of those limitations are. I think there's also been a question there from Kate.
Yeah, so Kate said, I'm curious how, if the Zodiac tools implement the use of governance tokens and streamlining the process of token voting and delegating tokens. So the Zodiac tools we haven't built anything for kind of creating governance tokens, but we have built integrations into, or are currently working on integrations into other platforms or with other platforms that do kind of token weighted voting. So some examples of that are obviously the reality module and the SafeSnap plugin that plugs into Snapshot, which is one place where a lot of DAOs do token weighted voting. In terms of delegating tokens, Snapshot uses this delegate registry that we built to enable delegations. To optionally enable delegations as part of the settings for any space. We haven't done much outside of building that delegate registry in terms of streamlining the process of delegation. But I think when I talk about delegation, I think I'm less, like kind of delegating responsibilities, I'm less thinking about how you might delegate your vote weight kind of at the root level of an organization to other people, although I do think that's also a scaling mechanism, or sorry, like an efficiency mechanism. That's obviously the mechanism that Compound, the framework, has used for, or Compound / Open Zeppelin governor framework uses for making participation in DAOs more cost effective. Smaller users would presumably delegate to some larger user who can justify the gas cost of participating in governance. But when I talk about delegation, I'm more thinking about how you delegate around specific responsibilities. So you think in a kind of more traditional organizational hierarchy, you might have, say, multiple teams or departments, each of which has a focus. You might have an engineering team and a marketing team and an operations team, and the kind of sub teams within that all have kind of autonomy or relative autonomy over some subset of the activities that the organization as a whole takes part in. And so that's the kind of delegation that I think is probably necessary in some DAOs in order to create more efficiency. So you may have still the top level of the DAO operate as it does currently. Maybe some subset of proposals still go straight to the top level when you're talking about kind of really large budget allocations, or perhaps the proposal is to delegate some authority to a sub team at the kind of next level down. But then ideal case is that the top level DAO kind of does these relatively large proposals for kind of treasury allocation or for delegating different permissions relatively infrequently. And then you give those teams that you've delegated authority to autonomy over kind of decisions at the lower level. Ideally with some kind of checks and balances if they start to misbehave, or some leash that you can kind of reel back in if they start to misbehave or kind of act outside of the interest of the DAO as a whole. But yeah, I think that's more what I'm talking about when I'm talking about delegation. Orca protocol is a really good example of this. This is a relatively new DAO framework that's built on top of the Safe. Essentially creates a kind of tiered structure of safes within safes within safes that all act as kind of subgroups or kind of pods within a larger organization. So I'm I guess looking forward to that becoming more pervasive, because it's a really cool setup and I think very practical for the DAOs to scale beyond where they currently are.
Sounds awesome. Sounds awesome. So what I might do now, so thank you very much for your talk. I think that was absolutely awesome. Yeah, so I think everyone's doing their electronic clapping and all that business. I'm going to share a slide of my own here, which is the forthcoming talks. And oh, there we all are. I always find it disconcerting when Zoom suddenly flips the video off screen. I find that really worrying. But anyway, we have got a stack of talks booked, and there are even some talks that aren't in this list yet. So next week, I'm actually going to give a talk on smart contract and Solidity security. And it's going to be one of those talks that might actually go for about an hour, maybe an hour and a half, including question time. So it's going to be hopefully reasonably comprehensive on what to do. Horacio is going to talk about the Ethereum reference tests and really drill into what they're about, how and why, and really talk about his thoughts on them and how they could be improved. Ermias is planning to do a talk on cross-chain transaction security, and given the extremely recent Nomad hack, we've actually discussed maybe he should just talk about Nomad and like how Nomad worked, what the problem was, but also the post-Ethereum, who exploited and how, and try and track down those addresses and try and work out who's involved. And there's a lot of great information out there already, but I think there's a lot of extra insights could be done. So anyway, he might just do a general cross-chain security talk, but he might focus on that Nomad hack. And then we're going to have Paul Ashley talking about DIDs. And then we've got the chief scientist of Chainalysis is going to come along and do a talk on that. And then we've got Lachlan and Ming-Feng talking about their PhDs after that. Socials. So if you're at the meetup, you'll find this talk and all the others on YouTube. There's a Slack workspace. If you're watching this on YouTube and you're thinking it'd be great to turn up live so I can ask tricky questions of the speakers, then please just click on that meetup link and join the meetup. Every now and again, there is example code, and if you want to get a copy of it, just have a look there in that GitHub repo. And of course, as always, there's a formal methods reading group as well. Join the Slack workspace and join the formal methods channel within that. And then you can find out about when the talks are and review the papers. So where's the stop sharing? All right. And so that's all from me. And so thank you again, Oren. That was really interesting. And it'll be great to see the developments of this technology and essentially that pipelining of technology. It sounds really exciting. So cool. Thank you for giving a great talk.
Yeah, cheers. Thanks for having me. It was a lot of fun.
Thanks, Oren.
Yeah, cool. All right. Talk later, everyone. Bye-bye.
Thank you so much.
Thank you.